YouTube. In this video I'm going to confront how we multiply complex numbers either in standard form or not, but basically we treat this very much like we do algebraic expressions. So let's just go ahead and look at these couple of examples that I have here and we can talk through the methods for doing so. But I notice that I have 7i times the quantity 2 minus 9i. So one thing I do want to mention here is this. It is not worth our time in this instance to do so, but we can look at the 7i as some purely imaginary number because it has no real part. We're just multiplying that times some complex number 2 minus 9i. And the way we would treat this is we would just FOIL. But again, it's not worth us doing so because if I have something that's just a single term here, a monomial times this binomial, we can just go ahead and distribute it through. And what I notice I get here is this. I get 7i times 2 would give us 14i. And then if I took 7i times a negative 9i, well 7 times negative 9 is a negative 63. And that I times I is going to give us an I squared. So it is worth noting here in this video, recall that I is equal to the square root of negative 1. So to carry out this squared I, we would say it's the square root of negative 1 squared, which gives us just a negative 1. So really the value of I squared is negative 1, which rewrites this original equation, or we can rewrite it as 14i. We'd say negative 63 times a negative 1, or in other words, we would get a positive 63 here. So we'd say, rewriting this in standard form now, we'll put that real part in front, 63, we'd say plus 14i. This would be the value of that product that we just found. So before we move on to this next one thing I do want to mention is this. Whenever you're stuck with an I squared being multiplied by something, or even divided by something, what you could do is you could really just cross that out and make the sign of the thing that it's attached to the opposite, because what you're really doing is multiplying or dividing by a negative 1, okay? So keeping that in mind now in this next problem, I do see two complex numbers being multiplied, and we would call these binomials, even though they're not polynomials in and of themselves. They have two terms. So what we're going to do is we're going to FOIL these out. So we'd say 5 plus 4i times the number 6 minus 7i. We would get a new complex number in standard form, but let's go ahead and carry out our multiplication. So we have 5 6's, which is 30, and then 5 negative 7i's. Well, 5 times negative 7 is negative 35, and we'd have an I. And then I'd say, okay, well, 4i times 6 is positive 24i. And then last but not least, we would say 4i times a negative 7i. Well, 4 times negative 7 is this negative 28, and I times I is just I squared. So simplifying this, there are a couple of things we can do here, and we should do. First thing is this. We'll go ahead and combine our i's in the middle. We have negative 35 and a positive 24 would give us a negative 11 total of those i's. And then last but not least, we'd say, well, this I squared here is really a negative 1. So I will actually show my work here. I would get this. And I have to do my multiplication before I do my addition and subtraction. So let's go ahead and say, well, this negative 1 times a negative 28 is actually going to give us a positive 1 times a positive 28 here. It's going to flip the sign on this. So that positive 28 now and the positive 30 are going to give us 58 total constants, or 58, pardon me, total real parts of this number. And then we say minus 11i. And this will be our new complex number in standard form.